Okay, so in the last unit, we talked a whole bunch about expressions. If we take two expressions and put an equal sign between them, we've created what's called an equation. So an equation is a statement and two expressions are equal. And equations can be true, they could be false, they could be another possible answer. Okay? So for example, I've given you three equations here. Okay? How can you tell they're equations? Well, they've got statements on each side. These ones have numbers on each side and some operations on the left. This one has a variable on one side. Okay? Has a number on the right. But they're all equations because they have an equal sign between them. Is the first one true? Yes. Why? Because 5 plus 3 is obviously equal to 8. So that's a true equation. What about the second one? It's false. 7 minus 4 does not equal 2. What about the third one? What? Okay, why are you doing that? Perfect. Depends what x is. If x is 4, it's true. If x is any other number besides 4, it's not true, it's false. Okay? So what do we do with equations? Well, here's an algebraic equation. An algebraic equation has a variable that you're trying to find the value of. Okay? So this is what we do. And what do we do when we find the answer? That's called solving. And that's different from what we did in the first unit. In the first unit, we simplified expressions. We don't solve expressions. Okay? We solve equations. So what are we trying to do when we solve? We're trying to find the value of the variable that makes an equation true. So in this algebraic equation up here, we were trying to find the value of x that makes x plus 5 equal 9. Make that true, which is 4. And what do we call that answer when we solve equations? We call it the solution. Another word that you probably haven't heard before when we talk about solving equations, we can also call them a root. That's not to be confused with square roots. It has nothing to do with square roots. Okay? When we find the answer to an equation, we're either finding the solution or we're finding the root. But we'll stick with solution for this year. Okay? But as we move up into later math courses, we're actually going to be using this word. And how can we solve equations? Well, we could do it mentally if it's easy enough. Like the first one, x plus 5 equals 9. I think all of you would be able to say, yeah, well, x is 4, because 4 plus 5 is 9. Like if I give you this one, you'd probably be able to tell me mentally what x is. 2, because 5 times 2 is 10, right? Yeah. So some of them are pretty straightforward. Once they get a little bit more complicated, though, we need another method. And we call it inverse operations. What we're doing, or what we will do, is a series of steps to get the equation by itself. So for example, and you don't have to write this down yet, we'll do ones like this. If I had this, okay, that's a little hard to do in your head, especially if the answer is a fraction, which it could be, okay? So what we want to do when I say inverse operations is we want to get rid of everything that's with the x on the left-hand side so that just x is by itself. And then our answer will be on the other side. That's the goal of solving equations. And why can we do this? Well, think about it. If you add the same value to each side of an equation, the equation always stays true. So I think you would all agree, this is an equation, 5 equals 5. If I added 4 to each side, what would I get? If I added 4 to each side, 9 equals 9, right? Is that still true? Yes. If I took 5 equals 5 and subtracted each side by 10. So what does this look like when I subtract each side by 10? -5 equals -5, which is still true. Same thing works when we multiply both sides by the same number. Same thing works if we divide both sides by the same number. So this allows us to use this inverse operations. Okay. Now, like I said, many equations, many simple ones you can do in your head. Okay. But I do want you to get used to using this. So we're going to use some pretty simple ones to start with that you could do in your head, but I would want to show you how we do it using inverse operations. So this first example, I think if all of you looked at this, you would be able to do it in your head. So yeah, x is 7, right? The 7 plus 3 is 10. Here's how we would do inverse operations. And I think you guys did some of this in middle school. Yes? Not sure? Maybe? Okay. So right now, on the left, I got x plus 3. I want x by itself. I want to get rid of this. How do I get rid of plus 3? Subtract 3. But remember, in order to keep the equation true, you got to do the same thing to the other side, right? So I'm going to subtract 3 by this side too. What's left after I do that? Well, there's just an x equals 10 minus 3, which is 7. Okay, so we only had to do one inverse operation. Like I said, a lot of these you can do in your head, but sometimes step ones can be a little tricky. Like this one. May not be obvious. Some of you may think 4, or some of you may think 20. Right? So maybe it's not quite that obvious. Here's where inverse operations really helps. What do I do to get x by itself here?
Add 8.
Add 8 to both sides. Those disappear. What does the equation look like when I'm done? What does the left side look like now?
X.
Just as an x equals -12 plus 8 is -8. That's our answer. That's our solution. And the nice thing about equations is you can always check them to see if they work. Okay, I'm not going to ask you to do this every time, but if I want to Like, let's say I'm doing this on a test and I want to check to see if my answer's right. Plug -4 back into the original. Does -4 subtract 8 equal -12? Yes. So -4 must be my answer, must be my solution. The next one. The y is not by itself. What is with the y? A 6. Are we adding 6, timesing 6, dividing 6? What are we doing here? Okay, but what are we doing here right now? Like before, don't tell me what to do to get rid of it yet. This is multiplication, right? So it's y times 6 or 6 times y. So you're right. I have to get rid of the times 6 by dividing 6. Remember, we wouldn't subtract 6 there because it's multiplication, which means I'm going to divide this side by 6. So my answer is going to be y equals, careful, -8. This next one. This is one where students sometimes get confused on because they think they have to add, they see a -8 and they think that they have to add 8. But it's not, this is not -8. This is times -8, right? Because it's -8 times z. So how do I get rid of 8 times -8? Divide by the exact same thing, -8. And those go. Which means I'm going to divide 6 by -8. Yep.
Do you want it in decimal or
Leave it as a fraction that we're going to do. Because I want you guys to get used to leaving them as fractions. Remember what I said. This doesn't divide cleanly. Okay? Don't go to decimal, but reduce it if you can.
why is it negative on the bottom?
Because how do we get rid of a times -8? Like, how do you get rid of times 2? Divide 2. How do you get rid of times 10? Divide 10. Same with negatives. How do you get rid of times -3? Divide -3. Yeah, same idea. That can reduce to what? -3/4. And remember, you can put the negative in the middle if you want. You can leave it down with the 4. That's fine. Just don't put 2 negatives in there. Okay. So those are what we call one-step equations, because it takes one step to get the answer or the solution. The most common ones you guys are going to see are two-steppers. Okay, where we're going to have to do 2 inverse things to get the variable by itself. And pretty much when we solve any type of equation, you can get it down to a 2-step equation. So let's say we got 4x plus 5. Oh, sorry. Thank you. Sorry. I'm going to do these first. Okay, so this one, you got to make the equation first before you solve it. How do I translate this English into algebra?
X.
No, I don't tell me the answer yet. Just convert this to an equation. So, yeah.
So I should do y because x is the times.
Okay.
So y times y times 3 equals
Okay, but how do we say that in algebra? Y times 3. 3y. Right? You don't go y times 3. We go 3y. Is translates to the symbol equals. negative 27. So we haven't solved it yet. All we've done is translated it to an equation. Yep. All right, so now we got to solve it. I got to get rid of this times 3. Divide by 3, get rid of it, which means I've got to do the exact same thing to the other side of the equation. So my answer, final answer is going to be y equals negative. Perfect. So you can see, like, it's 3 multiplication. A number means pick a letter, and you can pick any letter you want. Just make sure it's lowercase. So we could have done 3x equals negative 27. We could have done 3h equals negative 27. Any letter you want. The most common one we use is x, but it doesn't have to be x. A number divided by 4 is 1.5.
Like x over 4 equals 1.5.
Perfect. A number, so variable, divided by 4 is 1.5. Translate. How do I get it by itself here? How do I get rid of divide 4? Do the reverse. Times 4. That divide 4 and divide 4 cancel each other out, which means we've got to do the exact same thing to the other side, times 4. So what does the equation look like? Well, we've got x by itself, which is what we want. 6. And there you go. This one does involve a decimal, but normally we use fractions. Okay, sometimes we'll see decimals when we do equations, but this is fine. Okay. Okay, so that's 1 steppers. 2 steppers. We're going to do the same thing, except this time we need to get rid of 2 things to get x by itself. We need to get rid of this right beside the x, and we need to get rid of this, right? Both of them. We're not going to do them both at once. We got to do it in 2 steps. That's why they call it a 2-step equation. The question is, which one do we do first? It's important the order that we do this.
But I feel like we're like addition, it's a process to take out the other number and then do self for x.
Exactly. It's reverse. Because we're going in reverse, think reverse order of operations. So addition and subtraction go first. Multiplication and division go next. Okay? So I want to get rid of the plus 5 first by doing what? Which means I've got to do the same thing to the other side. What does the equation look like after I do that? Sienna? Oh, sorry. Sienna? Right. There's 1 step left to get x by itself. Divide. Yeah. Divide 4. Divide 4. I've got x by itself now. I'm going to get the answer on the right.
Negative 11.
Good. I know I'm jumping ahead of myself a little bit here, but you guys are eventually going to reach the stage where you're going to do the red parts in your head. Like you're just going to write this, then this, then this. Okay. I suggest for 2-step equations now, I suggest doing this to start just to get comfortable with it. But you guys will reach a point with solving equations where you're going to do the red ones in your head. And that's okay. There's nothing wrong with that. Okay. So let's look at these things. A is very similar to what we did in that first example, that first two steps. What am I going to do first? Really? Add 3 to both sides, so those cancel out, and I'm left with 4x equals -12. Still got to get rid of the times 4. Divide 4, which means I got to do the exact same thing to the other side. So I'm left with x, and then my answer, -3. See if you can try B. B is going to give you a fraction answer. I'll give you that as a hint. Don't let the fact that that the T isn't first and the 8 is after. Don't let that throw you. What's that? Yeah, you get rid of, remember, this is multiplication, so we get rid of that last. So I got to get rid of 8. Subtract 8. Yeah, sure, let's keep going. No. Let's keep going here. So we subtract 8. Be careful. What are you left with? -16 equals 3. Don't forget to carry that negative down. Remember, this is not -6. This is times -6. So we don't add. We divide by the exact same thing. Which means I've got to divide the right-hand side by that. Yeah. Yeah, go ahead. Perfect. Because we can reduce 3 over -6 to 1 over -2. Or, like I said, if you want to put the negative in the middle, that's fine too. Both of these are right. Either of those are right. And the last one. Now this one gets a little tricky at the end. Hopefully you guys should know what to get rid of first.
13.
The 13. And what is that going to leave you? Right. Now, we don't have x by itself, do we? We've got -x, so we haven't found the answer yet. We're really close. But think, what number goes here?
1.
So isn't -x the same as times -1? How do you get rid of times -1? Divide -1. And they cancel. So on the right, I got to do 7 divide -1 for this one. So I'm going to get positive x, which I need, equals -7. Yes. You got to go further. It's not wrong. It's just not completely simplified. Okay. So that's sort of the basics for solving equations. From this point, we sort of get into some more complicated equations. What if we have variables on both sides? That's sort of the next step that we look at, but we'll look at that next week. Let's just get comfortable with these right now. So for Wednesday, exercise 6.1, please. Okay. And those of you that are still in testing mode, just tell me whenever you want to start. If you want to review for a bit, that's fine. If you want to just go, that's fine. Up to you.